The cooling system's tasks are to quickly reach the engine temperature, maintain a constant operating temperature, and prevent overheating. The cooling circuit also allows the vehicle interior to be heated. A rapid rise in engine temperature is achieved by the thermostat, which is generally located directly on the cylinder head. When the engine is cold, the thermostat is closed, and the coolant circulates only in the engine. The coolant circulates through the cylinders and cylinder head, and is returned to the water pump through an internal pipe in the engine block. Once the operating temperature has been reached, the thermostat opens, and at the same time the internal return line to the water pump closes. The coolant is forced to flow through the radiator. A small amount is fed to the expansion tank, which allows the coolant volume to be compensated in relation to the coolant temperature. The coolant flowing through the radiator is cooled by the airflow. If there is insufficient cool air, the temperature will rise, and a thermoswitch located at the outlet of the radiator pipe will switch on the radiator fan. The cooled coolant is returned to the water pump via an external coolant pipe. When the driver switches on the vehicle's interior heating, a valve opens and coolant flows through a heating element. The various interior ventilation settings regulate the speed of the fan that blows air through the heating element. The cooling circuit is shown schematically below. Rapid rise in engine temperature due to a small amount of coolant circulating inside the engine. The thermostat opens the large cooling circuit and simultaneously closes the small cooling circuit. The coolant now flows into the radiator and a small amount into the expansion tank. If the temperature is too high, a fan switches on to cool the coolant. The temperature control opens a valve that allows hot coolant to circulate in the heating element. Adjusting the fan speed will vary the airflow through the heating element.